Hello guys, in today's class we shall discuss the effect of leakage reactances in practical transformer. Okay, so what exactly the leakage reactance is, why it is necessary to study here. Up till now we have discussed what only the resistances are the only thing which is causing drops across the resistances. But as a matter of fact it is not true. So along with that we have one more drop, that is drop due to leakage reactance. Okay, and again let us see how the leakage is occurring, why it is called as leakage and all. So till now what we discussed, that is whenever we give supply to the primary winding, what happens, an EMF is induced due to the flow of current and all. So flux is starts to flow from one electric circuit to the another electric circuit through the core and all. Yes, till now what we understood, that is 100% of flux whatever is produced here, so it is what travel through from this part to this part. So 100% of interaction is done with the secondary winding. But as a matter of fact it is not so. If say 100% of flux is produced over here, means say whatever the value it may be, only like what 80 to 90% like this. Okay, 80 to 90% of, or exactly we don't know how much of percent links to the secondary and all. But one thing I'm sure, that 100% of flux is not interacted, means it is not inducing EMF. 100% of flux will not help to induce EMF over the secondary winding, means some of the flux is lost while coming from this point to this point. How it is lost? You can see that in this flux, instead of traveling in the core, yes, it is traveling in the air. Yes or not? You can see this flux is, primary flux is traveling in the air and it is completing its path through the primary winding itself. It is nowhere linking to the secondary winding. Yes or not? So this flux is gone waste. Similarly, one more dotted line is shown. Similarly, this is also a flux. Just for sake of convenience, like this, plenty of lines you can draw like this. Just has to show this is due to the this is the leakage flux, and it is not interacting to the secondary winding. Only the one which is flowing inside, it is interacting the secondary winding. So due to this leakage, what happens? It offers an induced EMF called as small e suffix L1, means EMF induced due to the leakage reactance in primary winding here, due to the primary leakage flux phi L1. It is shown over here. Okay, see EL1. Okay, this is the self-induced EMF caused due to the primary leakage of flux, primary leakage flux, which is linked to the primary winding, that is 1. Okay, so it is self-induced EMF which opposes the supply voltage V1. So my V1 has to overcome EL1 so as to supply the main EMF E1, capital E1. Hope you understood. There are two aspects here. One is capital uppercase E1, that is main induced EMF. Okay, one is small, that is lowercase EL1, that is self-induced EMF which opposes the supply voltage. Leakage flux flows here in the air and completes path in the secondary winding. That leakage flux is called as phi L2. It's okay, and due to this what happens, there we get induced EMF EL2. Okay, now my main EMF E2, that is capital E2, should overcome this small EL2 so as to supply the load voltage V2. Okay, so EL1 is also drop as well as EL2 is also drop. EL1 is the drop in the primary winding, whereas EL2 is a drop only in the secondary winding. So how to account this, how to formulate this, right? EL1, so EL1 can be written as what? I1 into X1, whereas EL2 can be written as I2 into X2, where X1 is the reactance present in the primary winding, whereas X2 is the reactance present in the secondary winding. We have to account anyhow, yes or not? Because the formula is EMF, so we know the product of current as well as resistance, yes or not? So resistance here in our case we have it as in terms of reactance, because we know that reactance also has SI unit ohms. So it is what? I1 into X1 for the primary winding, whereas for the secondary winding it is I2 into X2. Okay, so this you should remember. Along with the drop I1 R1, I2 R2, we have drops of I1 X1 as well as I2 X2. Okay, This is what they given, leakage reactance of primary winding, whereas X2 is leakage reactance of secondary winding as well. So I1 X1 is nothing but simultaneous union of, you can just write it as EL1 is equal to I1 into X1, whereas EL2 is equal to I2 into X2. Okay, so how to reduce the leakage flux then? Yes or no? Leakage flux means in here it is not contributing in supplying the power as well. Yes, we can reduce this by wounding on winding primary as well as secondary on the same limb, central limb, for a shell transformer if I am going to use. So in that case what happens? Leakage flux will be less. But for this what happens? Leakage flux is more. But if I use shell transformer and all what happens? There we are wounding primary and secondary winding on the same limb. So what happens there? Leakage flux will be less. Okay, and the losses will be also less. Hope this is clear. So now we'll see equivalent leakage reactance. Okay, similar to your resistance, reactance does exist because we know that your transformer is inductive type, so reactance does exist over there. So what happens? In similar ways we will account this also. Okay, so your X1 is very much similar to your R1. Okay, and X2 is very much similar to your R2. X1 is the leakage reactance present in primary circuit, whereas X2 is the leakage reactance present in the secondary of your circuit, that is secondary winding. Okay, and we were knowing that R1 is equal to R1 plus R2 dash. Yes, hope you remember this. R1E was equal to R1 plus R2 dash. Similar ways you can write this, that is X1 equal to X1 plus X2 dash. And where R2 dash was equal to what? R2 by K square. True. Similarly, X2 dash is equal to X2 by K square. Only change is what? You have to replace X by R or R by X. You will get the same formula. Everything, these suffixes, everything are all same. So X1 is what? Leakage reactance when referred to the primary. Similar ways we can write leakage reactance when referred to secondary, that is X2E. The formula remains same as that of R2E. R2E was equal to R2 plus R1 dash. Similarly, X2E will be equal to X2 plus X1 dash. Very much similar. Just replace R by X. The formula will be all same. And where R1 dash was equal to what? K square into R1. And here X1 dash is equal to K square into X1. Very much similar. And remember, your K value will be always same. That is N2 by N1 equal to V2 by V1 is equal to I1 by I2. That is the formula which you need to remember. Okay. Now, since we have accounted leakage reactance as well as winding resistance, so now we will account combination of both leakage reactance as well as winding resistance, or winding resistance as well as leakage reactance. So if I want to account both combiningly, then I'm going to call it as what? Equivalent impedance. Okay. So initially in the diagram we were having R1 as well as R2, then what came? X1 and X2 came into picture. Now we are combining both of them. R1 and X1 present in the primary winding, whereas R2 and X2 can be combined in the secondary winding. So R1 and X1 combiningly can be called as what? Total impedance of primary winding, that is Z1. Z1 is the total impedance of the primary winding. Similarly, Z2 is the total impedance of the secondary winding, where Z2 is equal to R2 plus JX2 and Z1 is equal to R1 plus JX1, imaginary. Okay, R1 plus IX1 you can call, otherwise R2 plus IX2 you can call. Okay, Z1. Z1 is the what? Total impedance of primary winding, whereas Z2 is the what? Total impedance of secondary winding. Okay, same thing we have written over here. Okay. Now if I want to take just magnitude, I don't want everything angle and everything. Imagine if I want to remove that everything, then what I can do is I can take mod and square them. Okay, you can take mod here. If you want to remove this reactive everything, only if you want magnitude means you have to take mod. What mod law says? Take mod on both sides, and what happens? Square. It's not square on both sides. If I take mod means what happens? R1 square plus X1 square. Square if I remove means what happens? Individually have to square there. Square root of R1 square plus X1 square, which you know. Similarly for the impedance of the total impedance of secondary winding, that is R2 square plus X2 square. So similarly we were having R1E, X1E, right? That is resistance referred to primary, reactance referred to primary. If I add R1E and X1E, then I will get what? Total equivalent impedance when referred to primary. Okay, don't confuse between Z1 and Z1E. That is Z1 is what? Z1 is the impedance referred to the primary winding. So it has what? R1E plus J X1E in it. And similarly Z1 is nothing but what? Same thing. R1E was equal to what? R1 plus R2 dash. X1E was equal to what? X1 plus X2 dash. Similarly, Z1E is equal to Z1 plus Z2 dash. Again, replace X by Z over here. Again, same thing. This formula remains same. We are knowing that R2 dash was equal to R2 by K square. X2 dash was equal to what? X2 by K square. Now here also same. Z2 dash is equal to Z2 by K square. So this is all with respect to the primary when referred to primary. So here you can see the total equivalent impedance referred to secondary. So Z2 is equal to what? Same formula, R2E plus JX2E. Same. Okay. Again Z2 is equal to what? Z2 plus Z1 dash, where Z1 dash is equal to what? K square times of Z1, similar to that of R1 as well as X1. It was K square times of R1, K square times of X1 there for resistance and reactance respectively. But for impedance it is Z1. And again, if you want to take mod of this, that is only if you want to take magnitude of this, means you can take mod on both sides. Again, what? Square root of R1 is square plus X1 is square, and Z2 is equal to square root of R2 is square plus X2 square. You can write Z2E in this form as well. Z2 is equal to K square into Z1E, whereas Z1 is equal to Z2 by K square. And how this formula came? By taking this into consideration. Okay. So this formula is also, we know that Z2 is equal to Z2 plus K square into Z1. So what I'm going to do is, since it is with respect to Z2E, so I'm just bothering over this. When I comes for Z1E, I will consider this formula. Okay, Z2 is matching, so I'm going to consider this. So what I'm going to do here is, I'm going to take K square as common from this. When I take K square as common, so what happens in the bracket? I will get what? Z1 plus Z2 by K square. Yes or not? Yes, K square if I take common means Z1 plus Z2 by K square. But Z2 by K square is nothing but what? Z2 dash. And now in the bracket I will be having what? Z1 plus Z2 dash. And we know that Z1 plus Z2 dash is nothing but what? Z1E. So that can, whatever the terms present in the bracket can be replaced by Z1E. So Z2 will be equal to K square into Z1E. Okay. Next, if you want to calculate how Z1E came, it's very simple. Again, consider Z1E formula over here. Okay. So now what you're going to do is, I'm going to take common here. What common? Tell me. Yes, I'm going to take 1 by K square as common. If I take 1 by K square as common, in the bracket I will get what? K square Z1 plus Z2. Yes or not? Because I need to multiply this if I'm going to take common here. K square Z1 plus Z2. But K square Z1 is nothing but what? Z1 dash. So Z1 dash plus Z2. Yes or not? So I'm going to get what? Z1 dash plus Z2. So Z1 dash plus Z2 is nothing but what? Z2E. So the answer will be what? Z2E by K square. Okay. Very simple. Take 1 by K square common. Into the bracket I will get what? K square Z1 plus Z2. K square Z1 is nothing but what? Z1 dash. So in the bracket I will get what? Z1 dash plus Z2. And we know that Z1 dash plus Z2 is nothing but what? Z2E. Okay. So this is how this formula came. So and now I'm going to account like this. We know that R1 was present here, X1 was present here, R2 was present here, and X2 was present here. Now I'm going to refer to the primary. So when I going to refer to the primary, what happens? R2 will become R2 dash and X2 will become X2 dash. So R1, R2 dash togetherly I'm going to call it as what? R1E, that is equivalent resistance when referred to primary. Similarly, X1 plus X2 dash I'm going to call it as what? Equivalent reactance when referred to primary. So I can replace this whole term by R1E and replace this whole term by X1E. So R1E, X1E combiningly again I can call it as what? Equivalent impedance when referred to primary. Okay, Z1 is the equivalent impedance referred to the primary, not total impedance. It is equivalent impedance referred to primary. So it's combination of what? R1E plus JX1E. Okay, Z1 is equal to R1E plus JX1E. Similarly, I can do for the other part, that is for the secondary side. You can see I have transferred my R1 into secondary side. It becomes what? R1 dash. Similarly, X1 becomes X1 dash. So R2 plus R1 dash, which already we learned that it is R2E. Similarly, X1 dash plus X2 is nothing but what? X2E. And again, I can replace this whole term by R2E and replace this whole two terms by X2E. So togetherly, I can call what? That is equivalent impedance referred to the secondary. So it is 2. So Z2 is equal to what? R2E plus JX2E. So that's why it is written as referred to secondary equivalent impedances. So this first diagram was equivalent impedance referred to primary. Second diagram is of what? Equivalent impedance referred to the secondary. So very simple it is. Okay.